We're going to start on that. You're going to finish it this weekend. It won't take very long. Number 3 is assignment number 28. If you haven't written it down, please do so. Assignment number 28, you might be thinking, wait a minute, I already did this? Good. If you already did it, there's no need to go and do it again. But I think there's some stuff that maybe you're like starting to figure out. I would encourage you to go back and maybe redo some of those problems. You've got 4 days. I'm not trying to take up 4 days with calculus, although, man, that would be great. That would be fun. I am picking up assignment 28 on Tuesday. I am going to pick up assignment 29 on Tuesday, and I'm picking up the corrections, and I need all of them to be best case. All right, so number line test. The other day we talked a little bit about the number line test. We're going to get started. Jackie, does it say record? Jackie, does it say record on the screen?
Yes.
Last class had some problems. Okay. So we already did a little bit with the number line test the other day, which was meant to be a review of pre-calculus. So I think most of you guys are going to be okay. But last class it became really obvious that they weren't sure why you would use a number line test. How do you know to use a number line test? Here it's pretty obvious. The title of the handout says number line test. Here's what I look for. I know, side conversations are done here. I know I'm going to use the number line test if I have no graph. Okay, no graph is given. And I want to do comparisons to 0. Because your number lines, like, I'm just going to sketch a little number line over here. I don't even care what the numbers are. Your number lines always wind up looking something like that. A number line is a way to graphically organize your thoughts. So you can say, oh, I know where the roots are. I can figure out where the graph is positive. I can figure out where the graph is negative. If you can get yourself to a place where you're trying to compare to 0, number line test is the way to go. Unless if you have a graph, and then the graph is so much easier. So let's look at this question. F is the function defined by f of x equals 3x to the 5th minus 5x to the 4th. What are all the x coordinates for points of inflection? Points of inflection. If I'm paying attention in calculus class, I know that there are 3 different ways to find a point of inflection. F has a POI. Maybe you just want to make some notes on the side. What are any one of the 3 ways? I'll take anything from anybody. How do I find a point of inflection? F prime changes from increasing to decreasing. Half right.
Or changes from decreasing to increasing.
Okay, or changes from decreasing to increasing. That is true, Roberto. That is a way that we go find a point of inflection. There's another way. There's 2 more ways. Has to do with F double prime. Kevin, tell me about F double prime.
Changes from positive to negative.
Positive to negative?
Or negative to positive.
Or the changes from negative to positive. There's one more way. It just means that F changes concavity. Okay. That's what it means to be a point of inflection. You were concave up, you are now concave down. Or you were concave down, you're now concave up. All right, you might say, well, what the heck does this have to do with this problem? What does this have to do with the number line test? I know right now, the only thing I know right now is that f is equal to 3x to the 5th minus 5x to the 4th. What's that graph doing? Where does it change its concavity? Without a graph in front of you, you don't know. So I wouldn't, although it's true, f changes concavity, I don't have the kind of information or the tools that I need to figure it out. Well, what about f prime? Do we have f prime?
Yeah.
Do we know f prime?
Yes.
You could all find f prime, right?
Yes.
Take 3 seconds. Go get me f prime. Don't call it out. Don't call it out. So get me f prime. Make sure you know how to find f prime. Pedro, this one's coming your way. Pedro, what you got for f prime?
15x to the 4th power minus 20s.
Perfect. Now we've got f prime. Hey, I just need to know where f prime changes from increasing to decreasing. I still don't know. But I could go to f double prime. I can make f double prime. F double prime is, what is 60 x to the 4th. Oh my god. And that was hell. F double prime is 60x cubed minus 60x squared. Finding the first derivative and the second derivative, everybody totes okay?
Yes.
Okay. Why do I care about the second derivative in the number line test here? Yes. I can use the number line test. I can use the second derivative to figure out where do I make this change from positive to negative and negative to positive. And so how we're going to do with the number line test, you're going to say, all right, where is 60x cubed minus 60x squared equal to 0? You're going to make yourself a number line for f double prime, and you're going to figure out where am I positive, where am I negative. And I bet lots of you are fine doing this on your own, so fly. For those of you that need a little bit more support, stay with me. I need to figure out the roots. So this isn't a calculus question, this is algebra. 60x cubed minus 60x squared is equal to 0. What can I do? Legal algebra stuff I can do. I can factor, I think. There's a 60. And how about the x squared? If I factor out 60x squared, what do I have left? X minus 1, because I'm dividing when I do the factor. Most of you guys should be flying on your own here. Now I need the roots. 60x squared times x minus 1 is equal to 0. I think I know the roots here. 0, and the root over here? X equals 1. Those are the roots. The roots go on your number line. There it is. That's not it. That's not done. Don't fall for it. I tricked the last class. Okay, 60x cubed minus 60x squared is equal to 0. I'm doing a number line test because I want to see where I have a change in signs. So guess what? I need to do my test values. So let's pick a number over here. -1. Let's pick a nice number between 0 and 1. I heard 0.5. I'm going to go crazy. No one is ever going to pick this number as their value, but stay with me. You're going to see something and be like, oh, I get it now. How about a number bigger than 1? 2. Oh yeah, I just heard somebody say pi. Sure. As long as it's bigger than 1. Roberto, stay with me. It's not just madness. All I care about is the sign, the SIGN of the answer. So let's plug in -1, and we plug -1 into the second derivative. You can plug it in here if you want to, I don't care. Or I like to plug in here at the factored place. It's easier to work with. What happens if x equals -1? 60 times -1 squared times -1 minus 1. Gosh, what is that? Hope it's not 0. 60 times -1 squared. -1 times -1 is 1, but all I care about is positive, right? 60 times a positive number, -1 minus 1, is -2, but I don't care about the 2. I care about negative. 60 times positive times negative is negative. Negative on that interval. Now let's look at 0.99. When you plug it in, 60 times 0.99 squared times 0.99 minus 1. No one in their right mind for this problem would ever pick 0.99. But I'm doing it to prove a point here. 60 times 0.99 squared is positive. No one needs to know that 0.99 squared is 0.9801. The fact that I do is a sickness. Okay? But it's 60 times a positive number. How about over here?
Negative.
Negative. Oh, I picked pi. For some reason, I picked pi. 60 times pi squared times pi minus 1. Everybody knows what this is. It's positive. I don't need to know that pi squared is, I don't know, it's 9 point six something maybe. Pi minus 1 is 2 point something. 60 times positive is positive. The number line isn't the answer. The number line is how you gather together the information to answer the question. The question was, what are all the x coordinates for the points of inflection? How many points of inflection are there?
One.
There's 1 point of inflection. F, so here's the final answer. F has 1 point of inflection. Where is that point of inflection? At x equals 1, because F double prime changes from negative to positive at x equals 1. Are there any other points of inflection?
No. Well, you don't know.
We do know that.
I know because all the intervals were positive.
In our number line, even though we only found 2 roots and we tested 3 points, there are no other roots anywhere. There's no place to make a change from negative to positive. So there is 1 point of inflection. We found it. We've got the number line. We've organized the thoughts. We're good. Yes, there were 3 possible roots. Part of the issue is this x squared. We would call it a double root. And that's so not what we're going to worry about right now. Okay, here's what I want you guys to do. Problems 2 and 3 are just going to be extensions of the work. I'm sorry, 1, 2, and 3 are extensions of the work that we've just done. Take a minute or two, see what you can do at number 1. We're going to pull it together and see where we are. Strange of you. Very interesting. Number 1.
So I have to do the exact same thing we did on the top.
Remember, that number line test is excellent for comparing things to 0. But that's all it's good for. Over the weekend, I'm changing assignments, doing all the things.
X equals 0. That's what it is. Isn't it X equals 0? I got negatives. No, because I'm dividing by. I'm dividing. Yeah, that's going to be really small. So, I
feel like it's like the answer.
the easy way out. Your calculator is not fun.
Yeah, because it's like going negative. Well, it's just like that, but
Exactly. But you can't really tell based on what you do. Unless it's like absolutely.
That's why he said try. If you
You can't be so sure that's exactly.
he knows what he's getting to
it could be a seven.
It could be anything. Wow.
I mean, could it go from negative to like
We don't know if that's right either. Because he could come up with some random number.
I don't know, dog. I just know that on one side it's negative, the other side.
I'll set you up for success.
She said the root
Give me a name. I'll make this person be here.
And then you said 6 like 0.
All right. So here's what I saw. Here's what I see. I see some of you x cubed minus 12x minus 24. You're like, hey, in the last problem we found a derivative, and I'm good at that. And in the last problem we found a second derivative, and I'm good at that. Great.
Yeah.
Okay. Yay. Yay. What is it that we're looking for? No, 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 no.
If it's decreasing.
Where f is decreasing, f decreasing means something to you. It means that f prime is negative. If I'm going to use the number line test, it's because you're trying to compare to 0. You want to look at f prime, not f double prime. F double prime has nothing to do with the problem yet. So now from here I just say, oh, that means 3x squared minus 12 equals 0. And if you're good, you just keep going. 3x squared minus 12 is equal to 0. I need to find the roots. Gosh, I could factor. So 3 times x squared minus 4 is equal to 0. Can we factor more? Sure. X minus 2 times x plus 2 is equal to 0. And we can find the roots real quick. X equals 2 or negative 2. Here's my number line. X equals negative 2, x equals 2. How many guys were with me so far? Like, this is the direction you were going. Okay, some people maybe just copied the thoughts from the last problem and went to f double prime. The reason that I'm looking at f prime here is I'm asking about where f is decreasing, which involves f prime being negative. Okay, now that we're all hopefully caught up, finish it off. Pick your test values. They don't have to be weird ones. They just have to be in the intervals that we care about. So maybe you're going to pick like negative 4. 3 times 4 minus 2 times 4 plus 2. 3 times 0 minus 2 times 0 plus 2. 3 times 4 minus 2 times 4 plus 2. Regardless of what you picked, I hope what you're getting is plus minus plus. Your number line ought to look like that. You didn't have to pick the numbers that I picked, you just had to pick numbers in those intervals. And no matter what numbers you picked in those intervals, it goes positive, negative, positive. How many guys had that? Okay. Good, 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 good. Here's the thing though. This isn't your answer. Go back to the question. What's the question? Where is f decreasing? Answer the question. F is decreasing when f prime is less than 0. Gosh, where's that? Where's f prime negative? On the interval negative 2 to 2 parentheses, not brackets, because we said less than 0. Positive, negative, positive. Okay, one last thing before we leave this problem. The number line goes positive, negative, positive, and I'm wondering if anybody knew when we got here that the number line was going to go positive, negative, positive. Does anybody know anything about that graph? 3x squared minus 12. Okay, Kevin's doing this for some particular reason. It's a parabola. Tell me more about this parabola. 3x squared minus 12 is a parabola opening up. It's just a little skinnier. What else? That vertex is at negative 12. If I asked you to sketch it, what would you guys all draw? I would hope you would draw something like that. It has 2 roots. Guess where those roots are? Negative 2 and 2. Before you get to the first root, where's the graph? Above the x-axis, positive. After the first root, but before the second root, negative, below the x-axis. After the second root, up above the x-axis. So if your graph skills are good, you can get to the number line test quickly. If your graph skills are not so good, do the number line test. Everybody okay? All right, keep going. And the reason we're not talking about number 2 on the quiz is it was just more number line test. So keep going. You guys got this. Stop by? Yeah, so you don't stop by at lunch. If you don't stop by, I'm going to assume you're going to have that line. I'm not putting you anywhere. That's it. You have your time to choose. Nuh-uh. It is 11:30. Sad panda. Okay. So just so we're clear, today, 3 things. Assignment number 28, having all the work. If it is just random letters on a piece of paper, oh my God, Circus Boy Crazy will come to visit the house. Quiz corrections, get them done, get them done, get them done. Assignment lesson 29 is what we were just on.